Hello everyone, my name is Suhas, final year student at NMIM Institute of Technology, NITTE. I am thanking Emertxe Information Technology for providing me this wonderful opportunity. So I completed my internship on IoT from Emertxe Information Technologies. And during this internship, we built a project called IoT based home automation solution. And I want to thank Ms. Jayalakshmi ma'am for her guidance and teaching. So now I am going to give a presentation over this project and what we learned during this internship program. Going to next slide. This is the content slide, and these are the contents which I am going to present, and also these are the topics which are learned during this internship program. In this internship program, we learned about C programming, IoT, embedded system, microcontroller, and so many topics. And in this project section, I am going to discuss about overview of our project, objective of our project, and design elements of our project, like how we designed our project to get the desired output, and so on. And going to next slide. This is C programming. C programming is a general purpose language, even though it is applied and used effectively in various specific domains. In this figure, we can see a structure of simple C programming. The first line contains file header. This file header contains title of the program, author name, date, place, and this type of information, etc. And the second line is preprocessor directive. Preprocessor directive is the first stage of compilation, and then int main, it's the main function, and then in curly braces we can write our project. And these are the topics that we learned during this internship program. So we learned about data types. There are 4 basic data types. They are character data type, which acquires 1 bytes of memory, and then integer data type, which acquires 2 to 4 bytes of memory, and float data type, which acquires 4 bytes of memory, and double data type, it acquires 8 bytes of memory. And then we also learnt about modifiers and qualifiers. And we learnt about array. Array is a collection of same data types, and we learnt how to create array, or how to declare array, and how to initiate or initialize array. And we learnt about functions, how to define a function, type of arguments and number of arguments given to the function. And we learnt about pointer. Pointer is a variable that holds the address of another variable. We learnt about pointer arithmetic, and we also learned 2 methods. They are pass by value and pass by reference. And we learnt about strings. A string is an array of character ending with null character. And we learnt about preprocessor, macros, and advantage of using macros over functions, and so on. And we learned about user defined data types and C++ programming. C++ is a procedure oriented programming language. In this slide, I am going to talk about Internet of Things. In this figure, we can see that how Internet of Things is used in various fields and domains. For example, in this figure, they are given that Internet of Things is used in logistics, healthcare, manufacturing, TVs, mobile phones, home monitoring, home appliances, and home automation systems. And it is also used in heavy machinery and transportation. IoT is a collective network of connected devices. IoT technology that facilitates communication between devices over the internet. IoT system works through the real-time collection and exchange of data. And in this slide, we can see some of the applications and examples for Internet of Things. Applications are, as in previous slide, Internet of Things can be used in automobile, in manufacturing industry, in logistics and transportation industry, and it's also used in business also. Now I'm going to talk about embedded system, and in this figure we can see the basic block diagram of embedded system. Embedded system consists of sensor, analog to digital converter, processor, digital to analog converter, actuator, and memory elements. Sensor measures the physical quantity and converts it to an electric signal which can be read by an observer or by any electronic devices or instruments. Analog to digital converter converts the analog signal sent by the sensor into a digital signal. Processor processes the data to measure the output and store it to the memory. Digital to analog converter converts the digital data fed by the processor to analog data. Actuator compares the output given by the digital to analog converter to the actual or expected output and stores the approved output. An embedded system is a combination of computer hardware and software intended to do a specific function. An embedded system are low cost, low power consuming small computers are embedded in other mechanical or electrical devices. Generally, embedded system comprise a processor, power supply, memory and a communication port. And in this slide we can see where we can apply this embedded system, and we can apply this embedded system in medical field, electronics, robotics, security system, telecommunication, automotive industry and so on. Then we learnt about the part of or components of embedded system. The embedded system basically contains three parts. They are system on chip, microcontroller and microprocessor and memory elements. In microcontroller contain analog to digital converter and digital to analog converter blocks, timer and counters, pulse width modulation, preprocessor, memory and input output ports. And we also learnt about microprocessor versus microcontroller and their advantages and similarities and so on. And we also learnt about memory elements. In that we learnt RAM, ROM and types of RAM and types of ROMs. And we also learnt about peripheral. Peripheral is the internal or external devices that connects directly to the computer or microcontroller. And in this project, we use so many peripherals like LDR sensor, CLCD to display the output of sensor, and temperature sensor and serial tank. In this slide, we are going to discuss about overview of a project. Our project provides an IoT-based home automation solution using Arduino Uno board in PiximLab simulator. Blynk IoT mobile application is used to control the devices remotely. We can control the lights and temperature of the room or home and inflow and outflow of water in the water tank using Blynk IoT app. In the next slide, we are going to discuss about objectives of our project. Connect the home appliances to the Arduino and integrate it with Blynk IoT app using Blynk Cloud. Control light, temperature of home along with the level of water tank using mobile app. Obtain notification about the status of home on the mobile phone. And in this we can also monitor or get the details of the devices we are controlling. Why home automation? Generally people always don't stay at home. This brings the problem of home appliances not being monitored. The solution for this problem comes out to be home automation. Home automation enables people to control most of the devices remotely, such as volume of the water present in the water tank, garden lights, temperature of the home, so on. We use Arduino Uno, so we are going to discuss about it. Arduino Uno is a microcontroller board based on Atmega 328P. It has 14 digital input and output pins. In that, 6 can be used as pulse width modulation outputs and 6 analog input and output pins. And these 6 PW pins are also called as digital pins. And it contains a 16 MHz ceramic resonator and a USB connection, a power jack to power supply and a reset button. Arduino can be programmed using different IDE, and in our project we used Arduino IDE to program the Arduino board, and IDE stands for Integrated Development Environment. Arduino IDE supports C and C++ language. And we also used PiximLab. PiximLab is an open source real-time emulator of development boards with integrated GDB debugger. It supports some Pixim microcontroller and some other microcontroller also. It has integration with Arduino IDE for programming the board microcontroller. We use Blynk IoT app And we also learned how to configure this app, and we learned how to create a new template, how to add devices, how to select and add data stream, how to create icons, and how to include Blynk library, and so on. And LDR stands for light dependent resistor. LDR is a 2-pin device, and in this figure we can see the resistance versus light intensity graph. As the light intensity increases, the resistance across the LDR is decreases. So LDR sensor is a light detecting sensor that detects the light that falls upon it. The photoresistor is a light controlled variable resistor. The resistance of the photoresistor decreases with increasing in incident light intensity. The LED lights are connected to the LDR via the analog to digital converter. The analog to digital converter converts the analog input by the LDR into its equivalent digital form, which is then converted later by certain formula from 0 as the lower bound to 255 as upper bound. Based on that, we glow the LED. For example, if the output is 255, then LED will glow to full of its brightness. If the output value is 0, then LED it will be completely off. And this is how we are using LDR to control the garden lights. We connected LDR sensor and LEDs to Arduino Uno board. The properties of LDR sensor is applied to accomplish the controlling of garden lights. During the day, the outdoor light is maximum, so the LDR sensor detects the light and the garden light is turned off. Whereas at night time, the outdoor light is very low, so the LDR sensor detects the low light and the light is turned on. And we also use a temperature sensor to control the room temperature. The temperature is recorded using LM35 sensor, which reads analog value. The value is converted into binary value and later actual temperature is calculated using the obtained value of the voltage. The sensor does not require any external calibration or trimming to provide accuracies of plus or minus 0.5 degrees Celsius at room temperature and plus or minus 1 degree Celsius over the range of minus 50 degrees Celsius to plus 150 degrees Celsius temperature. The output scale factor of the LM35 is 10 millivolts per degree Celsius. For instance, it provides an output voltage of 250 millivolt at 25 degrees Celsius, which means uh, if the temperature is rise or fall by 1 degree Celsius, then the output voltage of this LM35 will also rise and fall by 10 millivolts. This is how we actually controlling temperature of room by using that LDR LM35 sensor. We connected that LM35 sensor to Arduino, and we also connected CLCD to display and notify the temperature. And we are using Blynk IoT app to turn on and turn off the heater and cooler. We can also get notification on Blynk IoT app also. The temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler. Analog value of temperature is obtained from the temperature sensor LM35 and display it on the CLCD after converting it into digital value using analog to digital converter. Control the temperature of the system by turning on or off the heater and cooler through the Blynk IoT mobile app. And in this section, I am going to talk about water tank, that serial tank we are used in our project. Serial tank read the volume of the water in the tank through serial communication and display it on the CLCD. And it controls the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication and display the volume of water in the tank on the CLCD and also in Blynk IoT app. The tank refills itself when the outflow exceeds the threshold of minimum value 2000 liters, and it stops filling when the tank is full at 3000 liters. Gives notification to the Blynk IoT app. Now, it means when the maximum capacity of tank is 3000 liters, and when the capacity of water in the tank is less than 2000 liters, the inlet valve automatically opens, so the tank starts filling. And when the tank is full or at 3000 liters, it gives notification of blink out and the inlet valve stops. And this is the image of simulation of our project, and here it is LDR sensor, and we can vary the resistance across the sensor by varying this button. And this is CLCD display, this is LED which represent garden lights, and this is used for internet connection, and this is heater or cooler. This is temperature system. In conclusion, in summary, this project provides a solution of monitoring and controlling home appliances and certain devices remotely. Using Blynk IoT application and Pixim Lamp simulator, home automation project is simulated, where LED temperature system and serial tank resembles light, heater, cooler and water tank in real time. Blynk IoT application allows user to control these devices according to user's wish, thus accomplishing home automation. Thank you. And now my teammate Srinit is going to explain and demonstrate how project works.
Okay, this is a code which we have used in our project. This part is for IoT app, IoT Blink IoT authentication, which helps us in monitoring our code from mobile. Uh, the first part in our code is for uh, temperature system that is given here, and when the temperature is greater than 35 degrees Celsius, that is here, the heater should turn off because that is not a normal for a room temperature. And when temperature is less than 28 degrees Celsius, that is the actual room temperature that is shown here. The cooler should turn off here. That is the second part of our project, temperature system. And third last part of our project is about serial tank. When the tank volume is less than 1500 degrees Celsius, that is what we have taken in our project. And when less than 1000 degrees Celsius, the inlet should automatically turn on. And a notification should pop up saying that inlet valve is the water level is less than 1500 liter, so inlet valve is turning on. The maximum level is here 3000 degrees Celsius, 3000 liters, and when tank reaches the 3000 liter, the inlet valve should turn off. And whenever we turn on the outlet valve, the water should flow in opposite direction. Okay, first part of our project is about garden lighting. This is the LDR. When resistance of LDR is very high, garden light should turn on. That means it is night time and LEDs will glow. Uh, Next, when we decrease the resistance of LDR, the light should slowly turn off. As we can see, now the light is turning off and it is completely off now. This indicates that it is daytime and LEDs will turn off. Next part of our project is about temperature in a home, and as we can see, this is our Blynk IoT app which we are monitoring with our mobile. And when I turn on heater, the temperature should go till 35 degrees Celsius. When temperature is greater than 35 degrees Celsius, the heater should turn off, and we should get a notification in our mobile screen saying that the temperature is greater than 35 degrees Celsius, and heater will turn off automatically. Now if I turn on the heater, yeah, as we can see, the temperature is increasing slowly, and when temperature is greater than 35, it should turn off. Yeah, now we can see that the temperature has turned off, uh, and a notification is appeared here saying temperature is greater than 35 degrees Celsius, and heater is turning off. Now if I talk about cooler, when I press this cooler button, temperature should fan is rotating now, as we can see, and temperature is decreasing. The cutoff for temperature is 27.9 degree Celsius. At that time, at that point of uh, at that temperature, the cooler should turn off and notification should appear here. As we can see, notification also appeared here saying that the cooler has turned off because it is a normal room temperature. This is about our temperature sensor project. That is the second part of our project. The last part of our project is uh, about a cereal tank, and in the cereal tank, the maximum volume of water which it can store is 3000 liters. And now, initially, I have completely filled the tank. That means it is completely filled, and 3000 liters are filled here. Inlet is currently off as it is completely filled. Whenever I uh, turn on this outlet, the water should flow in opposite direction. That means it should empty the tank. If I turn on this, uh, yeah, as we can see, the water is decreasing. The cutoff what we have taken in this is 1500 actually. That is what we have made changes in our code. Uh, uh, and whenever it reaches below 1500, yeah, it reaches below 1500, the inlet should turn on. As we can see, the inlet is turned on now, and a notification has popped up here saying that water level is less than 1500 and inlet has turned on. Uh, Now I cannot turn off the inlet now because it has already reached the cutoff. Now if I turn turn off the outlet, it should increase again. As you can see, the water is increasing here, and notification will pop up here saying that the water is completely filled. Uh, Now if you see here, yeah, now notification has popped up here saying that enabled water level is 3000 liter water inflow disabled. Inflow is now disabled. Inflow will disable only when the water is completely filled or it is greater than cutoff, but below cutoff we cannot turn off the inlet. And now again, if we can turn on the outlet, and we can see that water is flowing in other direction. And I can turn off the outlet now. Yeah, as we can see, inlet has not turned on now because the cutoff has not reached yet, and water level is, and we can see here water level is 2250, and that is about our project. Thank you.